Hey students, we are going to talk more about electricity. And so this time, we're going to talk about current, voltage, and resistance. We're going to know what they mean, know the difference between them, and we're going to relate them to Ohm's law, which is the main equation that deals with electricity and can give us some really useful things to find. So, charge flows when there is a potential difference or a difference in potential. And I know that sounds like the same thing backward, but this is the definition of charge goes right in hand in hand with voltage. And so voltage is just the potential for current to flow. So think of it like water. Always relate the flow of current to the flow of water. And so if you have water on level ground, it's not going to flow anywhere. It's not going to go anywhere. So there's got to be some difference or voltage that allows current to flow. All right. So the flow of electric charge is known as current. It's abbreviated with a capital I guess just because they had too many other things using a C. And its units are amperes. So if you deal with music and electrical equipment, you know that you're dealing with amps and things like that. And that has to do with the amount of current that is flowing through the object. One way of measuring current is charge, measured in coulombs divided by time, usually in seconds. So it's literally talking about how many electrons are coming through in a certain period of time. All right. But we're always going to relate the flow of charge, current, the flow of charge, to flowing water. Voltage is the difference in electric potential. So we can also relate this to energy. Just thinking of potential energy at different heights. And even though we're not talking about different heights, we're just talking about an amount of difference, a possibility for current to flow from a place with one amount of voltage to another. So there must always be a difference or current won't flow. Current or charge flows through a circuit. Voltage is measured across so that there is a difference. Voltage, that difference in the potential it's got, causes current. It's abbreviated with a V and its units are volts. So they're a little more, they make a little more sense than the abbreviations and units for current. All right, resistance is how much a material resists or tries to stop the flow of charge. It is exactly what it says it is. If there is a high resistance, well, that means it's not letting a whole lot through. High resistance means a low flow, a low current. All right. Low resistance means a high amount of current is allowed to get through. So again, think of it like the flow of water. Okay. A small pipe would have a high resistance. It's only letting a little bit through. A wide, big pipe would have a very low resistance. It would let a lot flow through at the same time. Okay, so think of resistors like clogs in a bathtub. They're only letting a small amount through at a time. That would be desirable because certain electronic equipment pieces only need or want to use a certain amount at a time, or else you'll overload it and you'll break it. It'll blow. All right, so we have resistance, but resistance isn't set. It can change in some objects. So the resistance of some objects like our skin can change with its condition. We do have some resistance to electricity, but we do not want to test out this theory. So wet skin has much less resistance than dry skin. Salty wet skin, how could that happen? If you've been working out and so sweat is salty, or if you've been in the ocean, you have salty wet skin and it has even less resistance. So, you know, the whole never playing with electricity while you're in the water thing, this is why. Electricity is going to take the path of least resistance, just like water, okay? And so you do not want to be that path of least resistance. You want something else to be the path of least resistance so that the electricity will go through it. For most conductors, resistance increases with temperature. And so that's just another thing to keep in mind as our electrical devices get hot. It means we're having to spend more electricity to get it to it. So our electric bill will go up eventually. All right, resistance is abbreviated with a capital R, and the units are ohms, and they have the Greek symbol omega for their symbol. All right, so in brief, Ohm's law is current equals voltage divided by resistance. And you can rewrite that in several ways. And my favorite form is this way right here. V equals IR. It just, for me, is the easiest one to remember. This is the abbreviations of the one that's written in words up here. But V equals IR. If you know what they stand for, then you can rearrange that equation. You can use algebra. You can manipulate that equation to get whatever you need to be by itself. Okay, so power is another important electrical amount, and so it equals current times voltage. But as far as just dealing with these different quantities, all right, we have V equals IR. And so I have set up here, and I'll change it around before we use it, but next we're going to talk about circuits. And so this is a circuit setup. Light bulbs, they're going to work in the right circuit, but they've got some resistance too. That means that they're going to slow down the flow of electricity. Let's say that we know we're using a 9-volt battery. And we have measured that so let's say voltage, we're saying we've got 9 volts. Current with an I, we're going to say we've got 1 amp. So remember, the I stands for current, and this is an amp. It's the one that the letters don't match up as much, okay? But we could very easily work out this math and decide how much resistance that light bulb had. We would divide by 1 on both sides, and 9 ohms would be our resistance. Now that was really simple, and it was in there for simple numbers, and it would be better if we used an ammeter and put it across here and measured it. So an ammeter is a device for measuring current, but we'll have to let that be another thing for another day. So we could do that literally and see, knowing the voltage we have, measuring the current that we have, we could find the resistance. And there's a whole lot of other neat things that you can do with Ohm's law, with graphing. Remember that anytime you graph something, if we graphed voltage and current, well, if we did rise over run with this, the rise would be the volts and the run would be the current. And if we took this equation and said V divided by I, it would give us resistance. And so maybe later we'll come back and do an experiment where we can graph some voltage versus some current, and we can get a line and we can get the slope of it, and that would tell us the resistance of an object. Okay, so these are really good things when we can measure stuff. But V equals IR. So if you took that equation and were comfortable with it, then you could find out a whole lot of needed things about electricity. Also, as that previous slide said, power equals current times voltage. Well, what if you wanted to deal with something in terms of resistance and it's not in here for power? Well, voltage equals current times resistance. We could plug that in right there. And so power would equal current times resistance. And so this is another often seen equation for power. Anything times itself is that thing squared times resistance. And so that's just another way that you might see an equation for power in some book or at some point. Okay? All right. So we will continue to use these equations as we look at circuits, and we're going to do that in the next video. So for this one, we just wanted to differentiate between current, voltage, and resistance and use Ohm's law to find the missing variable. And so knowing that current is the flow of charge, Voltage is that difference in potential, that difference in energy that allows charge to flow. And resistance is literally how much resistance there is to the flow, whether there's very little resistance, so a lot gets through, or a whole bunch of resistance, so only a little gets through. And that those are represented in Ohm's law, V equals IR. And so we can use that to find any of those missing variables. Thanks for watching. See you later.